I think this next problem is so cool because normally when you're doing a matching function, you have A, B, C, and D, and you have four things on the left, and you have to say which one matches which. But look at this thing. We've got, I don't know, what is this, like 12 equations here? 1, 2, 3, 4. It's a lot. And yet, they're going to match to these four graphs on the right. So obviously, this is not a one-to-one matching, right? Some of these things on the left are going to all point to one particular graph. And we have to figure out how that plays out. The reason we get away with this is because sinusoids, that's sine and cosine functions, sinusoids are periodic functions, and there are multiple ways to describe them depending on your phase shift. Okay? Another way of saying that is, imagine you have a sine function, and it starts right there. Well, I have another sine function, and it starts right here, and goes like this way. Okay? And that's the exact same equation that describes both of those two things that I just drew in red. So let's get around to sorting this out. Let's see what we got here. I'll just start with the one on the top, okay? This guy right here. This is a cosine function. So we're looking for where, remember cosine functions start at the top of the wave. And I'm looking for where it is phase shifted 2 pi from the beginning. And it's not this red dot that I just drew, because that has a phase shift of 0. It's going to be this one over here. That is the top of a wave, which is at 2 pi. Okay, so that's what I want right there. That is A. And if we do the same thing with the next one, sine of 2 pi, x minus 2 pi, that one we're looking for a phase shift of 2 pi. Okay, where's that going to be? We want the start of a wave at 2 pi. So it's not this one, clearly not this one. Here we go. Third one down. See, that's the start of a sine wave, and the phase shift is at 2 pi right there. So this is C. And you're going to go through this same process for all of these guys. You're just going to find where your equation matches one of these four graphs. And every single one of the equations on the left will match one of the graphs on the right, sometimes more than once. I want to see if I can find one that is a repeat. Oh, here we go. Let's look at this guy. Okay, I'm going to look at this equation right here. I want a sine function which starts at the phase shift. What's the phase shift here? Remember, we have that sine flip to worry about. This is going to be a phase shift of negative pi over 2. So take a look in these graphs. Let's see what we have. Here's a negative pi over 2 right there, but it's a negative sine function. It starts going down. So that one's no good. Okay, we're not going to use that. This one is, that looks like a negative pi over 2, but it's a negative cosine function. It's the bottom of a valley, so that's no good. This is the top of a cosine function. That's no good. The only one left. Here we go. Negative pi over 2, and it starts going up just like a sine function. It starts at the middle, goes up. So this one is also graph A. So there's going to be some overlap in this.